Okay, now I'm going to explain to demonstrate the example that we're going to implement on the FPGA for this project of the microprocessor. So these are going to be the registers and data that we're going to load to the FPGA. We need to remember that the four most significant bits are going to be the instruction, and the four minus significant are going to be the address that we're going to point to load the accumulator, or to compare to the memory. So as we didn't implement an input, we need to load the accumulator as the first instruction. So we're going to load the accumulator with the data that are on the address 8. So in 8 we have and 6. So we're going to make this instruction. Let me reset. This is reset. This one is clock and 8 bits as the output. So we're going to make the start, fetch, the code, and these are the data on the 8-bit. We have right here and 6. So the next instruction are going to be an add. We're going to add on the address number 9. We're going to add a 4. So if we add 6 and 4, 6 plus 4, we're going to have a 10. So let's make this again. It's going to be start, fetch, the code, and now we have a 10. So now we're going to save this value on the position on the number 10. So we're going to make this again. It's start, fetch, code, and we have already saved it. So next instruction are going to be load the data that are in position number what is this one? 12, I think. Yeah, it's elementary. It's this one. So we're going to load a 4, and we're going to subtract this. So we're going to make start, the code, fetch, the code, and we make, one more, yeah. So subtract the result is going to be 4. Now we're going to, that was the load, we load the data from address number 9. Now we're going to subtract with the position number 10. In this case, we saved at 10, so we're going to subtract this, and it's going to be a negative number. We make start, fetch, execute, and now we have -5, -6 in this case, if we make this complement A2. And now we're going to increment the accumulator. So we make start, fetch, code, and now we increment number 1. So for the last instruction, we're going to load the accumulator with the direction number 14. Is going to be a 0. So we're going to make the instruction of jump if accumulator is 0. So we're going to jump for the last instruction. That's going to be the last part of the memory. So we're going to maintain here. So we're going to make start, fetch, execute, and now we have 0, and we're going to start here, and we are on halt. And this is the implementation of the FPGA. Thank you very much for paying attention.